Okay, good morning, everyone. Welcome to our final presentation. We're Intel Capstone team. I'm Yan. This is Zhimin. This is LiAng. And this is Lucy. This is Junying. So, this is the content for today's presentation. We're gonna start with introduction to our project, following with our detailed system design and implementation. Then the future improvement to our system, and we will finish our presentation with the difficulties we met and the lessons we learned in this project. So now is the project introduction. Our client Intel provides a lot of hardware to the manufacturers to produce different products. And before the system, the product design is ready to be manufactured, Intel side wants to make sure that the performance of the hardware on the products is eligible and meets their requirements. So this is the validation test phase. So currently they have separate systems for different manufacturers and products. And if one manufacturer wants to make this validation test, they need to contact Intel engineer, upload the file, and wait for their response and their analysis result. This costs time and energy and human resources. As more and more systems added into this phase, it is very expensive to maintain all these different systems, and the user experience here is not very desirable and consistent. Also, another problem is the data stored on each separate system can hardly be reused in the future. So in our project, we designed and developed an integrated validation system to serve these different manufacturers, different products, as well as other third-party users. In this validation system, everything is automated. The files uploaded to the system, then it will trigger our file management and data analysis. And after the file was all uploaded to the system, the manufacturer can log on to a web application to see the result. And since it is one system, we can reuse all the data on the system after that. And all third-party users like scholars and researchers can also participate in this process. And maintaining one system is definitely cheaper than maintaining multiple systems. So we got these requirements from Intel side, and the keywords here are HDF files, which is third-party file format, and the file storage structure and data structure. Also 5x5 validation test, which will be explained later, and the data analysis algorithm, the automation requirement, and the user-friendly UI with visualization of the report and insights of the test. Here is a system overall, and we can see it is a loop of the workflow. The users test and do the analysis and see the results. Here we can see our achievement we made during this project. The first one is automation. After the file uploaded to the system, as I have said before, that everything after that will be triggered automatically. And then we successfully deal with HDF files, and we read data from the files, and we organize the uploaded file on the server. And then is the aggregate analysis, which is a major analysis running on this system. It is the manufacturer at Intel want to see how the product's performance evolved along with time. So whenever they upload new files to the system, the file will be added to the historical data, and an overall aggregated analysis will run on this file and gather results for the current states. And then is the DDR products. This system is designed to accommodate different products. Now we have finished is the DDR product, which is the memory. And then we stored output the results and important intermediate results to XML files so that we can communicate using the SOAP protocol. And then we visualize all the results in the web application written in HTML5. We also employ other like JavaScript and the CSS to make the user experience better. And then this system can surely serve multiple users. They can use different devices like laptop, like a smartphone to have access to our system. And next, Zhimin will continue with our system design implementation. Thank you.
Hi. So this is our system design for our midterm presentation. And actually, when, as we follow up with this design, we find it's overly complicated, and we made several changes to make it more usable to our system. So in our implementation, we did some changes. There are two major changes. One is now we are using database and XML for the front end and for the result storage. And the database is used by the front end to store the user information. And the XML is used to store the results and the Intel benchmark and configuration, and also the summary file of particular user. And also, we reduced the number of services, and we simplified the logic to make it more usable. And we reduced our file service into two services, which is backend data-driven service and front-end user-driven service. So this is our new system design. And as we can see here, it is divided into two parts. The upper part is the data handle service, and the under part is the client handle service. So for the data handle service, when there is data coming in, which is a single HDF file, contains the test information for one system, one repeat, and it would be put into the data storage, and then it would be aggregated into aggregated HTML file, and which contains the important data to calculate our test result. And then we will run the data analysis against this aggregated data file and use Intel's benchmark to produce our summary and the test result. And for the front end, when the user logs in, we will use the database to check, to verify the user, and then we will get the summary from the summary file in the backend. And if it is real time, then the user will choose the product and the test, and so that it can retrieve the result of the particular test he wants, and then we will display the result in the front end. And the gray part is the modulars we haven't done yet, but we think it may be important for our system. So for example, when the summary and the test results part is done, there could be emails sent to the user to inform that his test has done, so that he can log into the website to check it. And now I will give a simple demonstration about how the data can be uploaded to our server side. So sorry about that. So now I will show how we can upload our data file into our service. So this is our local desktop, and there are 25 single files located in this folder, as you can see here. So if we go to this folder, and we can use as copy to copy all of these files to our server side. Oh, sorry about that. So we will use this command to send all of the files to our server side. As you can see here, this is our server's domain, and this folder is the folder that our backend our backend monitor will monitor. So if there is new coming file into this folder, it will automatically send this. It automatically process this file. So if we send this file to the backend, using this password. So the files will be sent there. It usually takes about like 4 minutes to process these 25 files. So meanwhile, let's go through how the backend would work at this time.
And the reason why it's 4 minutes is you put a timer in your phone.
Yeah. So
it's not actually 4 minute process.
Yeah.
Okay.
So this picture basically shows our backend model. It can be divided into 3 parts. The folder monitor here, file management, is one part, and another is check test update, and the third one is SOAP service. So these 3 parts are driven by different events, and they run parallelly. So for the first part, when there's a single HDF file comes in, the folder monitor will find out that this new file is coming and send the name of the new file to the file management. And the file management will check the content of this single file, and it will gather the information of the single file, such as the platform ID, user ID, system ID, so that it will know where to put this file and which user this file belongs to, so that it would copy the file into that folder and also aggregate all of the content from this file as a group into the aggregated HDF file. And also it will copy the important data, which is in different structure, but the content will be the same, and it would copy the data as a new group in the aggregated HDF5 data file. And the file management part is over now. So, and the check test update thread, it would periodically check if there is any new files come. So in our now configuration, we set 30 seconds to wait for each check. So when the check start, it will try to see if there is new single file comes, and it would check if that single file comes in within 1 minute. So if it is not within this 1 minute, it would run the test against this aggregated data file. But if it is in 1 minute, it won't do anything. So this configuration is used for efficiency reasons, because if there is like 25 file comes together, we don't want to run 25 tests. We just want aggregating 25 together and then run one test. So this is for this reason. So we create another thread for doing the check test update work. And for the SOAP service, it is driven by the front-end request. So if there is a request for particular user, it will send back the summary of that user. And if there is a request for particular test, it will send the result of that test back to the front end. And so for the file management part, we will show here it will generate these 3 files. And next, we want to show how we put our folders together so that each user can only access their own test and how their test is arranged. So in this part, the the main folder is the place that we place all of the user information and their test into this main folder. And this is set up in the configuration file in our system. And for each customer ID folder, it is specified for one particular customer, and it would contains the summary XML and the test result and text result, which is also XMLs. So these two files is used to send back to the front end to show the user the test result. And actually, this file hierarchy is quite similar to what Intel has instructed us. So, but we made some minor changes to make it more compatible with our front end, back end communication. And so, as I said, under each customer ID there will be multiple platforms, and under each platform there will be DRAM folders. So this folder contains all the system IDs and all the repeat for this particular platform ID of DRAM tests. And the combined base files contains all the content of the single files in the same folder. So this combined files basically contains all of these files as its content. So this is basically for the use of reference reasons, and the combined data file is used for the all the system and all the repeat. So it contains all the important data of the DRAM folder, and it is this file that is used to run the test, so that we can get the test result for that 5x5 system and the repeats. So this is our file management part, and Lucy will give more demonstration of the data analysis model.
Okay, for the data analysis model, we designed our Java classes based on Intel provided algorithm in MATLAB code, as well as the validation test data structure in C language. So we try to make it reusable and flexible to accommodate different products. So this is the upper level structure. It's the same across different products. They all have the following classes. In the test class, test is the main class that we calculate a health and a trust score. So indicates the performance of a system and how confident we are to the results. Say we have a product to be tested. A specific test includes 5 different system configurations, and for each system configuration, it will be tested 5 times repeatedly. So in the test class, we want to get the data for each direction across the dimensions. And for the lower level structure, it's different for different products. So this is an example of Intel product called DDR. So for this product, it has the dimension of channel, rank, and the lane. You can see that the hierarchical structure is similar to the previous one, and it is easy to extend to maybe different products. So how we get the health and the trust score? In our data model classes, we first calculate the statistics, such as mean and minimum values. With these statistics, we are able to detect outlier lanes. Then we remove those outlier lanes and recalculate the statistics. Now we have both data with and without outliers, and we are able to perform multiple checks and compare the results with Intel provided thresholds. So all the intermediate results, like detailed health and trust scores, will be stored in variables in order to display some of the messages to the front end. And after all the checks, and we either we increment the health and the trust score depending on if they pass some of the conditions. And for the implementation of this part, we decided to use one single XML file to take care of all the inputs, like the benchmarks, coefficients, and thresholds. So any future changes can be made through this one single file. And then I'm gonna hand over to LiAng.
So after all the data modeling and all the backend file system arrangements of everything, we will have a data visualization tool, which is built by a web application for the user to see the reports and data. So the front-end web application is we follow the MVC pattern, which contains model, and we use Hibernate ORM and MySQL. And for the view, we use JSP technology. And for the controller, we basically use a servlet. Everything is in Java. And for the front-end, specific front-end development, we use some third-party libraries like Bootstrap 3. And all the main components are made by Bootstrap 3 components. And we use jQuery to do some interactive design. And also for the charts, we have chart.js and Google Charts. And also we write some customized JavaScript to do a lot of interactive design. And this diagram will show the logic of the web application. So when the user want to use the web application, they will submit the ID and password to the login module, and login module will verify the ID and password. And if it is a verified user, it will send a request to the backend data service to request the user data summary. And after it gets this XML file, it will parse it and lead the user to the main page, which will show the user all the tests and all the products, so that the user can choose which one they want to focus on. They want to see the details, and if they want to see the details, they will click View, and the main page will request another detailed data from the backend data service, and parse the XML, and then lead the user to the test detail page, which the user can see all the charts and health scores, which has been calculated. So this is the basic logic. And for the front-end design, as you might remember, this is the design that we have made in our midterm presentation. And for the final deliverables, we have made some improvements on these designs. And then let's go to the demo time for the web application. So the web application has been deployed to a server provided by Heinz College, and this is the login page I have mentioned before. And first of all, we will see whether Jerome's data has been calculated and uploaded to the data service. Yep, and this is the one that Jerome just sent. You can see the date, and you can look into the scores and message. And so actually for this account, we only have one product, so and one test. So maybe we will use another account which has more tests to show all the to show the full functionality of the web application. Then this is the other account that has we have uploaded a lot of tests. So let me introduce some of the features in this web application. So first of all, we see this table, which will show all the products and tests. For each column, we have a filter that can show which product the user want to see and what the result the user want to see, because the data now are all not ready. So if the user want to see fail, there's no fail data, and they can select all data. And if the user want to see the specific tests within different products, they can go into the drop-down box and see all the tests they have made, and if they are curious about what is the details within each test, they can simply click view, and it will lead the user into this detail page, which will show all the data the user need to see. And for this page, first is the title, which is the test and the product name, and also the test date. And there's a drop-down list that the user can select which test they want to see for this specific product. And for each test, there's a health and trust score, which is calculated by the data model. And if the user want to see the specific details of each score, they can click view, and it will show all the details of how this score is calculated. And also for trust, there's the same thing. And because health and trust are two major stuff the user want to see, so we put it in the very if the user go into the detail page, the first thing they will see is the trust and health score, and after that there's messages telling them which part the user need to focus on, which messages. For example, for this test, the health and trust score are both low, so we will tell the user that the scores are low, and why the scores are low, because and there are some specific details the user can follow. And after all the messages, the user can we have the charts for the user to visualize the data the data flow. For example, here we have four different kind of charts, and as we discussed with Intel team, we get these four chart designs. And the first thing is the health and trust chart, which will show that for this single product, how the health and trust scores looks like from the first test to the last test. It will show how the user has been improved during this process, and you can put your mouse on that to see the specific score. And another similar chart is a combination chart, which will in this combination chart, the health and trust score are plotted as points, and it is connected by lines. So the purpose of this chart is to let the user see how they are making progress. For example, maybe in the first test they are in this point, and for the second point, for the second test they are in this point, and as time goes by, finally they may from not ready to pass and to very high score, so they can finally deploy the product and say that we can use this chip in our product. And also maybe they will keep failing. And the other thing is the eye chart, which will show the voltage and the timing and in 4 dimensions, and there are two eye charts. One is for reading and one is for writing. And in this chart, the user can see the shape of their data and compare those shapes with the Intel score, the Intel mean and Intel minimum, and their own minimum and mean. By compare these shapes, they can get some conclusions. And the eye chart and the last chart we made is the incremental chart, which is the counting for the assistance and repeats from the first test to the last test. So, for example, here we can see that there are 5 tests, and for the first test, the user made 5 repeats on this blue system, which is called this one, and for the second test, the user made 5 repeats on the green one, and at last they made 5 repeats on 5 systems, and this blue line will show the average number the user has made from the first test to the last test. Is just divide the total number of repeats divided by 5. So this is the all the data we want to show to the user, and also if the user finish, they can go back to the main page to browse other products and other tests. So this is all the functionalities we have in our web application, and you can log out. So yeah, so this is all for the demo, and then Junying will tell us more about the future improvements.
Thank you, LiAng. Next, I will talk about the future improvement of our system. So, for the future improvement, the first we want to consider is the security of our system, because in the current implementation, we didn't consider much about it. So, to improve the security, it's important to encrypt the data, use the public key infrastructure for the data that transmitted from the front end and back end. And for the data stored in the server, we also need to encrypt the data there to avoid the hackers from attacking the servers. And in terms of the user interface, it's very helpful to run more user tests because to improve the user experience, we can design some tasks for the users and ask them to perform them. And we can record the whole process and videotape them. From that, we can see if there are any drawbacks exist in our system, and then we can, according to their feedback, to improve our user interface. And for now, our user interface don't have any user management group, so it's also helpful for us to add some user management functionality to the user interface, so that the different users can have different levels of their user rights to access the data. The next is the data model part. For now, we can only test on the DDR product, so it's really helpful to adjust our data model and extend its schema and adjust the schema to accommodate to other kinds of products, such as the eMMC product. And now our result is exported to XML format, so we want to export it into HDF files to make the whole process more consistent. Next is the difficulties that we have come across in our project. So at the first page, it's very difficult for us to understand all the project requirements, And in the process, we have learned a lot of new technologies. And another factor that make our project difficult is the limitation of time and resources. So for the project requirements, because these systems is aimed to test the DDR product scores, so the lacking knowledge of the hardware make us spend a lot of time in learning and understanding all the product requirements. And in the backend implementation, we find it difficult to use the HDF5 library in the Ubuntu deployment. And in the data model part, we found it's difficult to transfer the MATLAB, the client's MATLAB code that clients provided us to the Java project because of the different logic and the multidimensional data structure. And in this process, we have to learn a lot of new technologies, such as the bootstraps in the front-end implementation and the JSP interaction when connect the back-end and the front-end, and learning the Hibernate when connect to the database. And we have used a lot of other third-party libraries in our project. And the limitation of time and resource also make us our project difficult because at first, as I mentioned before, we spend a lot of time to understand the user requirements and learn the new technologies. So the time left for us to implement the projects is really limited. And besides fixing the bugs in the system is really time consuming. So we have come across a lot of difficulties and we learn from this process. The first one is the efficiency of the communication. At first, we communicate with our clients once a week. We wire the video conference, but it's not very efficient. So we find more efficient ways to communicate, such as we use GitHub and share folder to ask questions and share our code. And next is the time management. So when we use the new technologies, it's usually we met a lot of unexpected situation, so which take us a long time to fix. So we learn to consider that situation and plan ahead of time. And finally, is the technology is improving, and we need to keep our pace with the speed of the new technology to make our project more perfect. So next year we wrap up our whole presentation.
Okay, so before I end up our presentation, I want to say thank you to our Intel team and to our advisors. Thank you very much for your trust and your decision to let us work on this project. This is very interesting and very challenging. And thank you. We appreciate your help during this process to answer our questions, to help us improve our management issues. And also, we thank you thanks to your patience and your prompt feedback to our questions. Thank you very much. We really learned a lot. By this project, we realized how much we have learned in this program and how much new things we could learn to reach our goals. And now we're open to any questions you have. Thank you.
So back to your challenges. Would you say that the unexpected part of the challenges was that added, 2x, 1.5x more effort than you had expected when you started scoping the project? In other words, in an ideal world, how much longer would you need to go do, or how many more resources would you need to do this time?
Since we have finished basic implementation and we need to work on the customized analysis, based on our current design, 1 more month would be the minimum
would
time.
More team members help?
Not really, because more people will take more time to understanding the requirement. But since we can divide our system into 3 parts, if we have another expert who ever deals with HDF5 files or deal with front-end design implementation, this will save us some time. But to understand these requirements and the initial requirements you give us has a lot of terms used in Intel, and at the very beginning we offer, oh, can we do that? But we use a month to figure out all the things. But now we totally understand what you're doing.
Would you suggest that when we start this, if you started over, that you would spend what amount of time to ramp up, take the baseline, the learning curve, right? So you could just go and start developing, architecting the model. How much time did you spend doing that? Roughly, percentage-wise.
Percentage, 30%? About
You
30.
spent 30 time trying to
Yeah,
understand
but
the
I think it would be helpful for you to provide the test data earlier so that we have a visualized.
It was also a learning curve for us.
Yes.
We all go through that.
And we were also doing development along the way.
Yeah.
So it was also another learning curve for us to try and understand.
Yes, and the way the data is stored in HDF5,
Yes.
the direction is actually the lowest dimension. But in the analysis, it is the uppermost dimension.
Okay.
And transferring this takes time to implement it. And Zhimin really spent a lot of time learning HDF5 files.
Very good.
Yeah.
Excellent. Yeah, I think, and then the second part here is a lot of the port you have to do from MATLAb to Java.
Because none of us has ever done anything with MATLAB.
Okay.
We just know that it's very useful, it's very powerful tool to deal with statistics.
You try MATLAB to C converters?
Yes, we during this process we use some online MATLAB application to try the code Adam gave us, so that we can really understand which dimension he is calculating the statistics, and the web application is really helpful.
I think one of the things our takeaway also, I don't see Adam, we were also thinking, I see Tim Buck on that. One of the things we realized that could have helped you was we could have built a simulator and data and given that to you earlier as well. Right?
Yes,
So you
yes.
could actually not have to go through that.
Since we're not familiar with the products and all the hardware thing, it's very good to give us visualized demonstration so that we can understand what's going on there.
For the future work, how do you see the visualization connect to this thing in future work? If I have multiple dimensions, I increase the number of features that we have today to, let's say, 20, 30. And I'm looking at some eyes are the first, the first time I tackle analytics, and just look at through my eyes and see which one are more important, which one is less important. So in the future work, yeah. Yeah. So how do you think about it? I have hundreds of dimensions, and I want to visualize it, and I want to say something about data or how my models are coming out.
Yeah, I think maybe in our design, actually, in the future, we want to make it as some customized analysis that the user can actually select, what time frame, between what time frame the data they want to see, and for which kind of data they want to see. And but since for the schema of our file system, it is now a little bit difficult to implement that. But I think in the future, you might need some database for the lookup, for lookup of which test and which product you want to see according to some conditions. I think in the future you might need some database to map some metric to the test files. I think
you have to do a capability or service that allow us to add in user-based analytics, and then map it, and graph it, visualize it. The visualization.
Because what happens if you're looking at a point at which you're interested in the visualization graph, you focus on that point and you expand it and then find out which features are more important for the point. And that's something analytics and graph work together. And because in any analytics, somebody is looking at a point of failure, a point of success. And to identify success or failure, you have to identify which features are more important out of 200 that you have. So this becomes very intuitive to somebody who's looking at. Whether you see the Google map, you keep on expanding.
Yes.
In the end, you look at a street level. And
yes. That's a very good direction for improve in the future. And for our current design, is mainly facing the manufacturer users, which is the reason that we make this UI more concise and simple to understand. But I know that for Intel engineers and for experts in the manufacturers, they would like to see detailed information and in more dimensions. And that's why it is necessary to add more add user group and add more UI templates for the users. If it is expert, they will be able to see more detailed data. And for the just the normal users, they would like to see the scores and see some general information. It's good to give them this simplified information. But it's very necessary to add that on in the future.
Yeah, because for a general user, pass-fail is good enough. But once it's pass-failed, it goes to the next expert level who tries to find out what's failed and which dimensions.
Yes.
Well, or I guess also for future improvement, it could be that we want to add custom analytics by the user. So
yes.
The environments which we can access the database of the data or the result data and do one analysis on it.
Yes.
A lot of time people come to me and say, I got 200 features. I'm looking at which one is important. Tell them I don't know. I mean, that's my first question to find out.
Yes, definitely.
And nobody can tell me that these 4 are important because I can always prove them off and say, no, the other 4 are important. So it basically becomes an ability for a normal user without doing too much of analytics to find out, these are 4 parameters that you have to care about while you're debugging the problem, not necessarily when you find the class.
Yes. We need another capsule.
That's such good news to hear. So gang, I think you do a fantastic job with this. In fact, when Christian and I spoke months ago, he kind of scared me with all the technical talk, and I immediately knew Terry was the guy to go for as a faculty advisor. But I knew we needed to have an A team to tackle this. So I assembled the team members based upon some hunches I had, some of the coursework we had taken. I think we really demonstrated you were an A team, so good job. But I want to ask you, coursework-wise, what was really handy? Classes that you either took in the core or electives that came into play here, or that provided transferable skills to learn some of these new technologies. Can you share some of that insight with us?
Java distributed systems,
right.
and the course you took.
Web application and development for the front end.
Okay.
Distributed system.
Yeah.
And Junying, any class.
Distributed system, I think, in my part.
Yeah.
A lot of blood, sweat, and tears, right? You learn everything else.
Maybe we need one more MATLAB course.
Okay, fair enough. Okay.
And another advanced web application course.
Okay.
Yeah, and maybe some user experience exploring course. Terry had sent us some slides about how to improve on user experience and how to evaluate that. I think that methodology is very useful.
Yeah, I think that's one of those things that a lot of students are not ready when they tackle these kind of tasks. And they know they want to develop some user interface that is really good and usable by users, but at the same time, they don't know how to do it. So, it's almost like every semester, whenever I have this moment that they don't know how to do it, I have to send these kind of references, which I got from HCI here. But there's really good methodology that students need to be aware of in terms of improving usability, not just based on your hunches. It's really based on these methodologies and then diagrams that they can get from the users, especially based on facts, not based on what you think it's going to be useful.
Another course is project management. Yeah, we need to deal with this agile project, and we need to know what documentations we need to do during this process, so that we won't be very panicked for midterm and final. We just get what we have and to organize the content and get everything. We have minutes for every meeting we have with our clients, with Terry, and our internal meetings. We have all the materials.
So that's news to the students in the room. Keep that in mind as you're getting ready for projects, upcoming projects.
That's good knowledge.
I have a question. What kind of difficulties you might expect in the future, like when you want to scale up the system and distribute all the data across different multiple machines?
Can you repeat your question? Sorry.
Because you might expect you will have a lot of data.
Yeah.
Like you might want to distribute the data to different machines. And I saw that you use MySQL as your backend for the data analysis.
No, actually MySQL is only used for storing the user information to login information.
Okay.
Yeah, but for the backend, we are using HDF5, and I showed the folder structure of that file. But yeah, as you said, that we need to store more data, maybe we will consider using like distributed file system and maybe HDF5. I'm not sure which one would be more suitable in this case. And we can also think about how to run multiple tests parallelly. And the thing is, with particular clients, there might be some conflicts, but if it's different clients, it's quite okay to run the test parallelly. So if it is the same, so we may consider using some global log for each user to. When we run a test against this user, we want to log this user, and so depending upcoming files or the new new test request will be hold back, and so that's basically what should be done if we want to make this whole system more scalable.
I just have another technical question because I don't know much about the HTML5 files. Yeah. So I want to know, does it support in-memory processing, or just you need to?
No, it's just like a normal file like you store in the drive. So yeah.
It is good for structured and unstructured data and for scientific purpose. Basically, all the data stored there are numbers, and they use different dimensions, different groups to combine all different data together. And it's very good for the data that is not a string or not a list, not an array matrix. It is for very complex data structure.
Actually, I do know that this actually may be a research area. Is that ACF5 does have a project that I think it's still fairly early for Spark. Right? They would go potentially in memory and go towards Apache and Spark. But that would require both a push from the research, because it's really driven by research labs in the scientific community. But from academic, that would also help make it more mainstream. We believe that type of hierarchical data is essentially you're attaching essentially as much of the definition of the context of that data in the header of the file, and then we're going to require applications and analytics to access that and then look at in the analytics. So that seems to be a more ubiquitous way of trying to standardize how data is stored in schemas that that can scale, right? That has a lot more flexibility as opposed to being more rigid, like going straight to an HDFS type big data today. Right? But that's it. That's a lot of research that needs to happen. Right. There's a lot of tool development that needs to happen. The team did a great job. We actually threw that in as kind of a major feature creep. We call it Intel, right? Major feature creep, and you handle it pretty well. So great job.
And your question?
What industry can benefit from this technology? What industry can benefit from this?
HDF5?
I mean, whatever your body is doing the data mining, what is like research or aerospace or
Let me give that a shot. So what we would like to go do is apply this towards manufacturing and scaling Intel manufacturing. So how we make silicon products and integrate in a framework to do data collection. This is a generic framework because today there are silos, applications, how we develop this inside of Intel today. We imagine that type of a framework is very consistent across manufacturing environments. In fact, our manufacturing environment is probably one of the most high-tech manufacturing environments. And we do have both Intel manufacturing along with our customer, who are the OEMs or ODM, right, original equipment and original design manufacturers that also have their platform level manufacturing. So this could easily scale out broadly into the manufacturing environment for both Intel and also our customers. So first answer to that would be yes, smart manufacturing would kind of be the place we'd like. And then you could certainly see how this could scale vertically up into the Internet of Things. So when you start standardizing, or at least having domains where we can actually define lower layer of data model, data schema that will scale and leverage this type of a framework, that can exist anywhere. Like it's just a Carnegie, has it in Intel, right? So now this can be portable to many different environments. Yeah. And then we talk a little about the future work, right?
Yeah. The architecture can apply to different areas, but the data model and this file structure won't be the same as Intel. This is very specific design towards Intel's requirements.
Right, but you could take the same framework and architecture and apply your own. Yeah. And then it could be highly leverageable. Sure. So question on specifically around the scaling part. So today, can you talk a little bit more about the actual infrastructure that you're building? So you have a backend, is that a separate server, and then the front end, which is a separate server?
Actually, both the backend and front end are currently on the same server, but it's easy to separate them. I mean, you can just deploy another server and put the front end there, and you just tell the front end where the self-service, what's the domain of that self-service, and you can connect them. It's quite easy.
Okay, so one other thing.
Two are separate.
Okay. But physically, the infrastructure is one.
Yeah. We only have one machine.
So along those lines, I think some of the future work and following up on the scaling question was from the performance, from the power, from a system scaling perspective, right? How would this type of solution scale, not just from file and data and analytics, but also from the infrastructure side? So how much is it going to cost me to host something like this? How much resources, how much compute, that type of answer. So I think that
if you want to parallelly doing this analysis for all the users and all the systems, one solution is you separate different users to different servers. One server just serves to certain users and just save their data on that machine. And then you make another maybe backup of all the data on the machines in another server. And another solution is you copy the existing data to different machines, and each machine can serve all the users. And that depends on how many users you want to configure or how many data there. For us, the data file not really big, maybe only.
Yeah, this proof point is right. But imagine we did this And we did this for Intel with the, 300 million silicon we ship a year, right?
Yes.
That's 300 individual
Yeah,
platforms that could be generating multiple times this data.
So if you have a lot of space, disk, hard disk.
There's a fundamental issue that you have to look at. We said in the future about security. When you have 300 million or billion data points, there are certain data that you cannot mix together. You need a complete isolation. And there are people who are doing research on data isolation because if you mix it and somebody else gets somebody else's data, it can be a big lawsuit for a company. So those kind of things, although they don't appear in the beginning, but then customers demand it. And how do you do that? I don't know if you can do it in a single server or not. That's basically a research problem.
That's a research problem.
A lot of people are looking for those kind of problems too. So don't look at 300 billion or million data as a single data. It could be same data but isolated from each other. And you may not be able to use the mixed data for analysis.
Now we separate the data from different customers in separate folders, and later we can actually divide them onto different machines.
That's where you have to see whether that's the right kind of isolation or not.
Yes, and we have made our recommendation on the security in our report about how to use public key, the credentials and other stuff current. We have a security, another security consultant help us to make this improvement. And yes, and to give us recommendations on this issue, and we have included that part into our report.
So, and then let me close out by scaling. And next work is for Intel, we would like to actually start leveraging this work and start scaling it out with customers, limited customers. So one aspect of this is to understand the commercial deployment. What we mean by commercial is that's exactly that. So right now it's just between Intel and Carnegie Mellon. But for us, the value of this is to start taking it in and making the modification we need, building the actual server and hosting, and either deploying at the customer or hosting it at Intel. And that's what we mean by starting down the path of commercial, to where this is actually it's a high impact tech project that we have to keep on scaling. So going back to the question about the scalability of the architecture, the system design, the requirements, to start looking at limited scale deployment, I think would also be a next step. I'd like, that the team should also kind of keep focus on it. So what would your recommendation be to go commercially deploy this, right, in that scenario? How mature is it? Are we ready to start looking at running this, or do we need to do a lot more development and testing and
definitely
tuning, right?
Because this is a prototype.
And
I think a similar case is Amazon's AWS, which is firstly used internally, and they push that commercially to the market. And I think there should be a lot of improvement built upon the prototype to think about how to deploy this on the cloud and to accommodate different situations, different products.
Yeah, so that...
I think that could be a good research topic, another capsule.
Yes, I agree.
Yeah.
Very good.
Very good. Does anyone on the market Intel have any questions?
I see a couple there.
Okay.
Hey Tim, I see you on there. Does anyone have questions who's online from Intel? I think it's early for one. they can play the video of the recording.
That's fine.
Yeah, and they will ask a question.
They'll ask me questions. That's why I'm asking all the questions now.
Yeah.
Well, again, gang, great job.
Thank you very much.
I really appreciate and enjoy your presentation. Thank you again very much.
Thank you. Thank you. Thanks, Christian.